Hi guys and girls, this is Miss Pashauer, and this is our last section of notes in Unit 8. Okay, Unit 8 has been a fairly long one. We did half of Chapter 7, the last half, and then all of Chapter 8. Okay, so our last section here of notes, we have 10 whole lessons, which is kind of a lot, but everything really kind of works together. In the first half of the chapter, we're multiplying polynomials going in one direction, and the second half we're factoring. Okay, so they're really just opposites of each other. We talked about this in class recently. In the first half, we're learning how to FOIL or how to distribute. In the second half, we're going in the opposite direction. Okay, so that first half of our chapter, this piece here that's in Chapter 7, is all this. Okay, how do I go from here to here, and here to here? Okay, the second half of our unit, which was Chapter 8, is basically going in the opposite direction. Given this trinomial here, can I factor it? Given this here, can I factor it? Okay, so they all really kind of work together. So this last lesson is nothing really new. It's just kind of putting everything together, which makes it a really nice lesson to think of as kind of like study tips or review or things like that. So we're going to look at a few tips, and we're also going to look at, kind of the entire process and just do a few practice problems. Okay? So let's get started. First of all, let's say we're given an example like this one here. Negative t squared plus 30t plus 35. Normally, if we're looking at that and we want to think immediately to start factoring into our binomial groups like this, we're listing factors, negative 5 and 1, negative 1 and 5. This could be a whole slew of different things. Maybe 1 and negative 1. Oopsie, let's write it like that. Gosh, what else goes in there? 5 and negative 5, 7 and negative 7, and then 35 and negative 35. Well, I don't think we'll need those. We'll see. And we're trying to get positive 30. Well, oh my goodness, that seems kind of tricky. Maybe I have this one here with this one. No, that can't be it. Negative 1. If I have 5, I have to. If I choose positive 5, I got to choose negative 1. And so now I am. Oh, this gave me a positive. This gave me a negative. Oopsie, I think I want this here. That makes 35, and this here that makes negative 5. And it kind of takes a long time because I have big numbers here, and I have big numbers here, and I have a negative sign here and a negative sign here. So if I were to factor it right away into my binomials, I would get 5t plus 5 and negative t plus 7. But I'm really showing you in this example not what to do. Okay, this isn't factored fully, even if we do get to this step. If you think about this one, we can take out a 5 from both sides, and we can take out here a negative 1. I don't really like to have negative variables here. So that's just what it says here, where I'll erase this so you can see it. There's a factor of 5 in each of these. There's a factor of negative 1. That would make that more simple. And so therefore we can take out a negative 1 and a 5, and we would eventually get negative 5 and then t plus 1 and t minus 7. But really the point I'm trying to make here is we should have checked for a greatest common factor first. Okay? That's really what I'm trying to get through to you guys here in this slide. This problem became much more difficult over here when I was trying to factor because I have bigger numbers that I need to deal with. Okay, so what I want you guys to think about first in your first step, if you're given a binomial, you first want to check to see, binomial, two terms, if it's the difference of two squares. Okay, if it's the difference of two squares, then you can factor it into these two binomial groups. If you have a binomial and it's not the difference of two squares, look for factoring out a certain common factor, like the undistributive property is what we say, to kind of pull that x out of this and x out of this. So this would be 2x minus 3. But if you're given a trinomial here, and when we're given a trinomial, we're usually always looking to factor it into our two little groups with the parentheses. Start first by looking for a GCF. look first by looking for a greatest common factor, because these numbers are pretty big, and they could have gotten much smaller, much faster, if I would have taken out the 5 that goes into all 3 of them. And remember, we don't like negative a, so let's take out negative 5. Okay, if I were to do this problem all the way over, and I lost what it originally said. If I were to start this problem all the way over and do it correctly, I won't go through the whole thing, but I'll show you how much easier it gets if we first start by looking for a GCF. So in our 3 terms, I can pull out negative 5, and negative 5. When I take out that negative 5, I'm going to get t squared minus 6t minus 7, yeah? And that's much easier to factor. You can see here how that would turn into t plus 1 and t minus 7. So I gave you guys a study guide in class on Wednesday, which goes through all of these steps. So hopefully you're thanking me, because you do not need to write down all of this stuff here, because it's already on that graphic organizer study guide that I had you guys use to study for your quiz. Okay, so it's already written there. Just don't lose it, and you don't have to write everything down. But our steps here basically factor out a GCF if we have one. Okay, look here for our greatest common factor. Hopefully you're seeing negative 2x, yeah? Let's take a negative 2x out of each term. If I take a negative 2x out of each term, you can see how this changes to become something, in my opinion, much easier to deal with. Now, is that the perfect square trinomial? Maybe. Let's look. What did we do here? Oh, 16. Yeah, it is the perfect square trinomial. 16 is the same as 4 squared. So now we're at negative 2 times, if you want to see this written out, it would be y minus 4 and y minus 4. Okay, because this is a plus, we need to have the same symbols there. Because this is a minus, we know that those are both a minus, subtract 4. Okay, when you're here, let's see if there's any common factors. Is there anything inside of here that I could take out? Doesn't really look like it. Check with distribution. All you have to do is go back and kind of FOIL it out and see if that's what you get here. Okay, this should be a chapter or a unit where it's always pretty easy to know if you have the right answer. You can check your work. You can go back and make sure it's right. This is just a review of what we did in class. Just to make sure you guys have that, you might want to take it out and kind of review it. Remember, our first step was to look for a greatest common factor, and when a is negative, that means to take out a negative 1. Okay? Look for any of these special cases, which we talked about in 8-5, the perfect square trinomials, the difference of 2 squares. If there are 3 terms, you have a trinomial, 1, 2, 3, something that either takes this shape here or this shape here, you're going to unfoil. When we unfoil, we're always looking for 2 products that make this, but then add up to that. Okay? When we make these matches, okay, remember, I am trying to factor this here. Okay? So I'm going to write the things that multiply to make 2. I have a 2 and a 1. I'm going to multiply, write down all the factors of 10. 1 and 2 and 5 and 10. When I look for something that will add up to make 9, and being that these are both plus signs, I know that my 2 inners and outers are going to add together to make that 9x term. And I circle these here in green. My 2 and my 2, that will make 4. And my 1 and my 5 will make 5. 4x plus 5x will give me that 9x in the middle that I'm looking for. And these 2 things that are circled together, the 2 and the other 2, remember, those are 2 things that I need to multiply. In order to multiply them, I have to have them be the inners as a pair or the outers as a pair. I put these 2 here as my outers. I put these 2 here as my inners. Okay? Again, just check to make sure that it gives you the 9x you want. These 2 here are my outers. The 2 and the 2 will give me 4x. The inners here, the 5 and the 1x, will give me 5x. Together, those make 9x. So if you're not sure, just make sure and check it by foiling it to make sure that you have the right thing. If there are 4 terms, try grouping. Okay? I'm not going to go through step by step everything we did in class because we already did this in class. But If you need to review it for yourself to study it, now's a good time. And then go back. Make sure. A lot of times when you group or, when you do any sort of factoring, you might think you're done, but you're not. Just make sure your groups can't be factored anymore. Okay, a lot of times one thing that they'll get especially stuck on is when they have something like this. It looks like a binomial, but that's the difference of two squares. So maybe I have I have that x minus 1 that was already there, but the difference of two squares can always get factored into x plus 1 and x minus 1 in this case. Okay, so that's always a tricky one. And then what I'm going to have you guys do are 4 example problems. There's 4 problems. Just try them out in your notes. Make sure you're getting the right answers. If you cannot factor it, it might be prime. Hint, hint. There might be a prime polynomial here. So if you stare at it for so long and all of your combinations don't work, it's possible that it's just prime. Okay, so I'm going to leave you guys with A and B. We can go over those in class. Try C and D now. Okay, start with C and D because I have the answers underneath these boxes here. Okay, this guy here and this guy here is the answers. So let's start there. Start with C and D. Press pause, and when you come back, I'll have the answers, so those we can check right here and now, and then A and B we'll check in class. Okay, so go ahead and start C and D. Okay, hopefully you're back and you're done. With C, hopefully you have this answer here, 2x times x plus 2 and 2x minus 5. With D, did you catch? There's a lot of work going on there. First you take out a p. Then you have p squared plus 1 and p squared minus 1. This one is done. There's nothing more I can do with that. This one factors. I gave you guys a hint in the previous slide that that's the difference of two squares. Okay, so if you have questions on those, bring them to class on tomorrow, and we'll go over them tomorrow. Hopefully we are feeling good about our objectives, just some tips, that whole process, and more practice. Okay, we should be feeling really, really good about factoring right now, okay? If you have any questions, bring them to class, and I will see you guys tomorrow. Have a good night.